cofactor, okay, you should be able to understand what determinants are and the notation used. Okay, before this, I've mentioned the notation for determinant. Okay, we use this notation, determinant. This is not a modulus. This is notation for determinant. Not a modulus. Or we can also use determinant in. Okay, second objective, calculate the determinants by using formula and then find minus and cofactor of a matrix. Number 4, evaluate the determinants by using cofactor expansion. Number 5, find determinants of elementary matrix. And then find the inverse of a matrix by using adjoint method. And last one, use Cramer's rule to solve the system of linear equation. Okay, these two objective is for application in determinants. Okay, first of all, we look at the definition of determinants. Okay, determinant is a real number obtained by performing certain procedure on a square matrix. Okay, this is for a square matrix. Only for a square matrix, we can find the determinants for a square matrix. Okay, the determinants denoted by this symbol. Okay, this symbol and also this. This is not a modulus, Okay, only square matrix have determinants and the value can be positive, negative or 0. So this is not modulus. Modulus always positive. But in this case, okay, this is determinant. So the value can be positive, negative or 0. Okay, determinant can be used to help us to find the inverse of matrix. Okay, this is another types how to find the inverse of matrix. And also solve the system of linear equation. Okay, with unique solution. Okay, we call it Cramer's rule. Cramer's rule. Okay, we will learn it after this in subtopic 2.3.3, application of determinant. Okay, let's look at how to evaluate the determinants of a matrix size 1 by 1. Okay, for matrix size 1 by 1, we can find the determinant by simply the entry of a matrix. Okay, for example, we have matrix size 1 by 1, 6. A equal to 6. Then the determinants equal to 6. Simply take the value of matrix, the entry of this matrix. And also B equal to negative 4 to 3. So determinant of B equal to negative 4 to 3. Okay, second one, to evaluate the determinants of a matrix size 2 by 2. Okay, 2 by 2. So for example, we have matrix A11, A12, A21, A22. So we use this formula. We have found this formula in previous chapter, right? Chapter 2. To find the inverse of matrix size 2 by 2 kan. Untuk ni. Okay, we use the formula AD minus BC. Okay, AD, AB. Okay, this one is B, CD. So AD minus BC to find the determinant of matrix size 2 by 2. So for example, we have matrix for A equal to 4, 1, 1, 2. So determinant of A equal to 4 times 2 minus 1 times 1. Then we get 7. For matrix B, B So AD minus BC, negative 4 times 2, okay, minus BC, 1 times 1. So we get negative 9. Okay, look at this, another example. Okay, matrix C equal to okay, 3, 2, 7, negative 8. Okay, what is the determinant for C? Determinant for C. Okay, AD minus BC. Okay, apa dia ni? Okay, saya tanya ni. Okay, Amira. Okay, Amira Akasha.
Negatif 38.
Okay, negatif 38. Okay, so apa? 3 times 8 by 3 times negative 8. Okay, minus 2 times 7 kan? So negative 24 minus 14. Negative 38. So determinant can be negative value lah. Okay, jangan awak positifkan pula bentuknya ni. Okay, this is to find the determinants for matrix size 2 by 2. Okay, for matrix size 3 by 3 and above, we cannot use formula. We cannot use this formula to solve the determinants. So we can use another methods in order to find the determinants for matrix size 3 by 3 and above. Okay, there are 3 methods. Okay, to evaluate the determinants for matrix size 3 by 3 and above. Okay, we can use, okay, first we can use Sorus rule. Okay, Sorus rule. Okay, Sorus rule is only for matrix. It's only to find the determinants for matrix size 3 by 3. 3 by 3 only for Sorus rule. Okay, number 2. Okay, second method, we can use cofactor expansion method. Okay, another methods to find the determinants. And last one, we can also use the elementary operation. Okay, elementary operation, this one is okay, based on row or column operation. Row or column operation. Before this, in chapter 2, we can solve the system of linear equation using row, elementary row operation. But in this chapter, to find the determinant, we can also use the elementary column operation. Okay, column. Kita boleh reduce based on column lah untuk determinant. Okay, first we look at the Sorus rule. Okay, to find the determinants for matrix size 3 by 3. Okay, suppose we have matrix A. Okay, matrix A 3 by 3. Okay, the first step of this Sorus rule. Okay, first you have to rewrite the first 2 column. The first 2 column of this matrix. Okay, rewrite the first 2 column on the right side of a matrix. We put on the right side of this matrix. Then we have the five number of column. Okay, then you have to find the S1, the value for S1 and S2. Okay, the value for S1. Okay, the blue color. Okay, the value for S1. The blue color is the main diagonal. Okay. Saya nak highlight ni. Boleh tak boleh? Okay, untuk main diagonalnya ni A11 times A22 times A33. Okay, plus the second main diagonal. Okay, blue arrow ni. A12 times A23 times A31. And then third main diagonal A31 times A21 times A32. Okay, we add on these three main diagonal to find the S1. And then we find the S2. S2 is, okay, for the purple arrow, A13 times A22 times A31. Okay, plus with the second main diagonal, second diagonal. A11 times A23 times A32. Okay, plus the third diagonal. A12 times A21 times A33. Okay, then to find the determinants, okay, equal to S1 minus S2. Subtract S1 minus S2. Okay, look at this example. Okay, find determinant of A by using Sorus rule. Okay, we add on first two column on the right side of the matrix. Then we find the S1. Okay, the S1 is the blue arrow. So 0 plus, okay, the second main diagonal, negative 12. Okay, the third main diagonal plus negative 2. So we get negative 14. And then minus S2. S2 is, okay, the purple arrow. Okay, so 0. Okay, the second one, negative 10. And the third one, plus 9. Oh, negative. Okay, negative 9. So we get negative 19. So and then S1 minus S2. So we get 5. Okay, ada soalan tak untuk ni? Ada?
Tak ada.
Ada. Okay, tengok contoh lain. Okay, we'll look at this example. Two, 1, 3, negative 1, 4, 1, negative 2, 1, 0. Okay, find determinant of this matrix. Okay, for example, this is matrix B. So determinant of matrix B equal to, okay, we add on first two column. 2, 1, negative 1, 4, negative 2, 1. Then find S1. S1 equal to the value for S1. So 0 plus, okay, 0 minus 2 minus 3 and we get negative 5. Then S2 equal to, okay, this diagonal, negative 24. Okay, plus 2 plus 0. So you get negative 22. Okay, therefore, okay, determinant of B equal to okay, negative 5. Okay, minus negative 22. So you get 17. Okay, faham? Faham ni? Ada apa soalan? Okay, boleh on mic lah untuk ni. Respon. Kita nak seorang.
Faham, madam.
Faham?
Faham, madam. Faham.
Okay, kita two-way communication lah. Tak faham, boleh terus tanya. Tak payah tunggu at the end of class. So, ada juga yang komen, mungkin saya laju kan. Laju you boleh stopkan lah kat mana yang tak faham. Kita macam dalam kelas biasa lah ni. Saya tak nak saya cakap seorang. Better, you all tak faham terus tanya. Okay, ni first method faham Sorous rule.
Faham, madam.
Okay, you can also use another methods to find determinants. Okay, by using a cofactor expansion. Okay, cofactor expansion is more complicated compared to Sorous rule. Okay, this method is used to find the matrix size, the determinant for matrix size 3 by 3 and above. 3 by 3 and above. Okay, for Sorous rule, only for matrix size 3 by 3. Okay, this is for 3 by 3 and above. Okay, there are two important concepts related to cofactor expansion. Okay, first, okay, if A is a square matrix, then the minor. You have to find the minor in this case. Minor Mij of the element Aij is the determinant of the matrix obtained by deleting the I and the row J and the column, the I row and the J column. We have to find the determinant. The minor is the determinant by deleting the I and J column. And then second one, to find the cofactor. Okay, cofactor denoted by Cij. Okay, the cofactor is the positive or negative value of minor. Okay, if I plus j is even number, so we have the positive minor. Cofactor is a positive minor. Okay, if I plus j is odd number, okay, this one is even number. If I plus j is odd number, okay, ni yang ganjil lah. Even yang genap kan. Odd is ganjil, okay, then cofactor equal to negative minor. So untuk yang ni, okay, the pattern of sign, okay, this sign, okay, depend on ni lah. Okay, normally the alternate kat sini. Okay, this one is A11 kan. A11 means 1 plus 1 is even. So that's why kat sini positive. 1 plus 1, 1 plus 1 is even. Okay, the second one is 1 plus 2 and 1 plus 2 is 3, 3 is negative. So negative, that's why ni negative minor. Okay, ni third one ni positive lah. 1 plus 3. 1 plus 3 is 4, 4 is even. That's why positive. So the alternate je lah sebenarnya. Positive, negative, positive. Negative, positive, negative. Positive, negative, positive. Boleh? The sign of cofactor. Okay, then the cofactor expansion method is carried out by expanding along any row or any column. Expanding of a matrix. If the expansion is along the first row, then okay, along the first row, this row, Okay, then the determinant of A equal to AII times A11 times C11. Okay, plus A12 times C12. Okay, plus A13 times C13. We can also use column, any column or row untuk ini to find the value always same lah. Tak kisah kita nak guna yang mana, value dia tetap sama untuk yang ni. Okay, look at this example. Okay, to find the minor and cofactor of a matrix. Okay, first of all, okay, find all the minors and cofactor. Okay, to find the minor of 1, 1, okay, we have to eliminate the first row and the first column. Okay, depend on this. M11, so we have to eliminate first row and first column. So, eliminate kat sini. Kita buang ni kan. So, we have to find the determinant of this. So, determinant equal to, okay, 10 minus 2. To 8. This is the minor for minor 1, 1. Okay, for minor 1, 2. Okay, minor 1, 2, we have to eliminate first row and second column. Boleh, maksudnya you all kena eliminate first row and second column. Okay, contohnya. Okay, we have to eliminate first row and second column. So we get the determinant of, okay, negative 3, 1, 0, 5. So we get negative 15. So this is for minor M12, negative 15. Okay, for minor M, macam kita cari yang lain M22. M22. Okay, so, okay, for minor M22, we have to eliminate the second row and second column. So we get the determinant equal to, okay, negative 1, 1, 0, 5. So we have negative 5. Negative 5. And you have to find the minor. Okay tak ni? The minor. Okay, example M31. Okay, this one. So M31. Okay, so we have to eliminate third row and first column. So we get 0 minus 2 equal to negative 2. Okay, so dah cari semua kan? All the minor and then find all the cofactor. Okay, cofactor depend on tadi kan, positive or negative value kan? Positive, so this one positive, negative, positive. Then alternate. Kalau boleh letak simbol lah ni, negative, positive, negative, positive, negative, positive. So you all check. Positive times 8 is positive. Okay, the second one. Okay, negative times negative 15. Okay, kat sini sepatutnya positive Positive 15. Cofactor 1, 2. Okay, and then third one. Positive times with negative, negative 6. So we get negative. Okay, ni cofactors 2, 1. Okay, negative times negative. Negative times negative 2. So we get positive 2. Okay, cofactor 2, 2, positive times negative 5. Okay, we get negative 5. Okay, negative times negative 2, we get positive 2. And then ni sama lah. Negative 2. And then cofactor 3, 2 is negative 2. Positive times negative times positive 2. Then last one, cofactor 3, 3. Okay, negative 2. So we have all the cofactor for this matrix. Okay. Then okay, if we want to find the value of determinant, this determinant. We can choose any row or any column to find this determinant. Okay, normally the tips we choose row or column with 0 entries. Yang mana yang ada 0 entries, biasa kita pilih kolom yang tu lah. Kolom atau row yang tu. Okay, for example, we have this 0 and 0 entries. So we can choose first row or first column or second column. Okay, any row lah you boleh pilih. Okay, for example, we choose the first row. We choose first row. Okay, determinant of A. If choosing first row, first row. So determinant of A equal to. Okay, so tadi apa formula dah? A11 times C11 kan? So A11, okay, kita terus je masukkan nilai dia ni. Okay, tadi kita dah ambil positif, negatif, positif kan? So negative 1. Okay, tadi kita dah cari kita punya cofactor. So C11, multiple with C11, 8. And then plus 0, 0 tak ada lah. Plus second ni 0 kan, tak ada. And then plus 1. Plus 1 times with the cofactor 1, 3. So negative 6. So we get negative 14. Okay. So macam tu kita pilih yang lain. Ni first row. If we choose first row. Okay, then okay, if we choose the second column. If we choose the second column to find the determinant. Okay, choose first column. Choose the second column. Now of A equal to, okay, the second column, okay, dia 0, 0 tak ada lah. So 0, okay, plus, okay, 2. Jadi positif, negatif kan? Positif. Okay, so plus 2, 2. Okay, this one. Refer on this one. So 2 times negative 5. And then plus 2 times with negative 2. And then negative 5 kan? Negative 5. So we get negative 14. Sama lah. Okay, faham tak ni? Cofactor expansion. Sebenarnya you all tak faham. You all tak perlu pun nak cari semua cofactor ni. Kita tak perlu nak cari semua cofactor. Kita hanya cari depend on row atau kolom mana yang kita pilih. Contoh you all pilih tadi kolom tu kan, we choose kolom tu, so kita hanya cari cofactor untuk kolom tu ni je lah. Kalau you all pilih first row tadi, kita hanya cari cofactor untuk first row. Depend pada row atau kolom mana yang kita pilih. Tak perlu cari semua cofactor. Okay, contohnya yang ni lah. Okay, second example, okay, compute the determinant of B. Okay, by using cofactor expansion, okay, expanding along the first column. First column. And also expanding along the second row. Second row. Better kat sini, kita pilih tips dia, kita pilih yang ada zero kan. Zero sama ada you all pilih second column ataupun second row lah, lagi senang. First row, first column ni tak ada zero, jadi you all kena buat 3 lah kan dia punya tu. Okay, contohnya expanding along the first column. Okay, so determinant of B equal to, okay, tadi kita okay, ni dia terus buat positif negatif kan ni. Positif, okay, kita positifkan. Kita buatkan sign. First we make the sign lah, alternate sign. Positif, negatif, positif. Negatif, positif, negatif. Dan positif, negatif, positif. Ni terus ambil alternate sign ni. So A11, 5. Positif kan? Positif 5. Okay. Multiple with M11. M11 is determinant, we eliminate first row and first column. So you get this. 0, 2, negative 1, 3. 0, 2, negative 1, 3. And then minus 1. Sebab sini dia ambil terus ni kan. Alternate sign dia negative kan. So negative 1 lah. Negative 1. And then we eliminate the second row and first column. So we get this matrix, negative 3, 2, negative 1, 3. Okay, ada macam mana? Okay, and then plus 2. This one plus 2. Plus 2. Okay, and then we eliminate the first column and third row. So we get this. Determinant lah, negative 3, 2, 0, 2. Okay, then we find this determinant. 5 times, okay, determinant 2, okay, minus 1 times, okay, negative 9 plus 2, okay, so negative 7, okay, plus 2 times, okay, this one, negative 6 times 0, so negative 6. We get 5. Okay, same with this, along the second row. Okay, second row tadinya ni. Sama lah operation dia. Okay, second row, okay, so dia akan jadi ini negatif lah kan. That's why kat sini dia ambil negatif, negative 1. So negative sign kat sini. Plus 0, 0 tak ada. And then ni negative, negative 2. Sign negative 2. So you get 5. Same value lah. Okay, and then we try to find the determinant. Okay, if we choose the second column, choose second column. You choose the second column. So the calculation apa? Second column. You look at this second column. So second column, okay, negative times negative 3 is 3 kan. Okay, and then we eliminate second column and first row. So we get determinant 1, 2, 2, 3. One, two, two, three. Second column Okay, and then plus 0, tak ada, plus 0. And this one, okay, negative times negative is positive. Positive 1. Okay, we eliminate second column and third row. So we get 5, 1, 2, 2. So 3 times, okay, determinant. Okay, 3 minus 4. Okay, plus 0, plus 1. Okay, 10 minus 2. So we get 3, negative 1, plus 1. Yeah. So we get 5. Sama lah. So the value of determinant equal to 5. Okay, faham? Ada soalan tak untuknya ni? So tak kira you all ambil mana-mana untuk cari ni determinant using cofactor expansion.
Faham je. Tak ada soalan.
Ada soalan?
Tak ada.
Tak ada soalan?
Tak ada. Tak ada.
Okay, tak ada. Kita boleh proceed. Okay, proceed with theorem. Okay, determinant of triangular matrix. Okay, determinant for triangular matrix. Okay, we can simply use this theorem. Okay, if A is an upper or lower triangular matrix, okay, of size n times n, okay, then determinant of A is the product of element along the main diagonal. So ni just ambil the product lah, the multiplication of main diagonal. First, you have to identify whether this matrix is triangular or not a triangular matrix. Okay, this matrix is triangular matrix kan? Okay, this is lower triangular matrix. Okay, so the determinant equal to the product 7 times the product of main diagonal times negative 2 times 1. So equal to negative 14. Okay, we can simply use this theorem. Another matrix, matrix B 5 times 5. Okay, this is the upper triangular matrix kan. So just darabkan je lah. Just darab dia punya main diagonal. Lepas tu 96. Okay. You all tak perlulah nak guna cofactor expansion tu. Just gunakan theorem ni je. Find the product of main diagonal. Okay, the last method, okay, we can use the elementary operation. Okay, this method is for matrix size 3 by 3 and above. Okay, 2 by 2. 2 by 2, we can also use this matrix 2 by 2. Normally, matrix size 3 by 3 and above. Okay, this elementary operation, okay, we can use the row operation or column operation to find the determinant of this matrix. Okay, we have to reduce it into triangular matrix form. Sini. We have to reduce the matrix into triangular matrix form. And then find the product of main diagonal. So first step ni lah. we have to reduce it into triangular matrix and then find the product of main diagonal. Okay. Okay, note that the changes that occur in the value of determinant when elementary operations are used on matrix A to obtain a triangular matrix B. Okay, if we use the interchange two rows, okay, there are 3 steps kan in elementary row operation. Interchange the row, multiplication a row with constant, and the third one adding multiple of row to another row kan. So kita kena tengok ni, dia punya ni. Dia ada dia punya rules dia lah. If we use the interchange row, okay, we must multiply with negative value of the new matrix. New matrix B, we have to multiply with negative. If we use the interchange two row. Okay, the second one, if we multiply a row with a constant. So for example, we have this, okay, we use the operation, okay, 2 row 1, okay, transform into row 1. Okay, we use this operation 2 row 1. Okay, then we have to multiply with, okay, 1/2. Multiply with matrix B. Multiply with a new matrix of B. Okay, this one multiple with determinants of B. If we use 2 row 1. Okay, if we use, for example, 1/4 row 2. We have to multiple 4 multiple with determinant of B. Rules dia ni 1/k. If we use k ni constant k row k times with row j, reduce into row I, so we have to multiply 1/k. Then last step, if we use the adding a multiple of one row to another row, okay, ni tak ada ubah apa-apa, ni sama je. Determinant of A equal to determinant of B. Okay, a combination of elementary row and column operation can be used to compute the determinant. Awak boleh campurkan lah untuk ni, row ataupun column. Okay, the triangular matrix obtained need not be in its row echelon form. Dia tak semestinya dalam row echelon form lah. Okay, elementary column operation cannot be used to solve the system of linear equation. Tadi saya mention kan, untuk column operation cannot be used to solve the system of linear equation. Column operation only for, okay, only for determinant, only to find the determinant. Okay, look at this example. Example 1. Okay, find determinant for this matrix, okay, by using elementary operation. Elementary operation. Okay, we have to reduce this matrix into upper triangular or lower triangular matrix. Okay, normally we reduce this matrix into upper triangular matrix kan, kita jadikan bawah 0. Ataupun you all jadikan lower triangular matrix pun boleh, jadikan yang atas 0 pun boleh. Dia depend lah. Depend pada creativity you all. Okay, for this example, okay. Okay, untuk ni dia akan first operation use row 1 interchange with row 2. ada interchange dulu kan. Interchange row 1 with row 2. So we get negative sign because we use the interchange operation. So interchange row 1 with row 2, 2, 4, negative 2, okay, 2, 5, 2. And then reduce, okay, reduce, we want to get this value is leading 1 lah. Leading 1. So we use operation 1 over 2, row 1. Okay, transform into row 1. So this operation 1 over 2 kan. 1 over 2, so we get 2 lah. Negative 1 times 2. Negative 1 is from first operation. Okay, 2 is from second operation. 1 over 2. So kat sini jadi 2. Ni. So 1 tadi daripada sini. So we get, okay, 1, 2, negative 1. So 2, 5, 0, 0, 2, negative 2. And then third operation, okay, reduce it. This 2 into 0. So we use the operation, okay, negative 2 row 1 plus row 2. Okay, transform into row 2. Okay, yang ni tak ada apa-apa untuk ni operation, this operation. So that's why dia maintain lah negative 1 and 2. So 1, we get 1, 2, negative 1, 0, 1, 4, 0, 2, negative 2. Okay, and then next step we have to reduce into triangular matrix. So these 2 must be 0, 0. So we use this operation. Negative 2 row 2 plus row 3. Transform into row 3. So reduce lah, dapat 0, 0, negative 10. So kat sini awak akan dapat ni. So this is in upper triangular. So just to find the determinant, just multiple this main diagonal lah. 1 times 1 times negative 10. Okay, multiple with this 2. Negative 2 times 2. So you get 20. Okay, dia mesti dalam bentuk ni triangular. Tapi syarat dia kat sini awak mesti jadikan 1, 1 lah ni. First row dia ada leading 1. Second row pun leading 1 dekat sini. Third row ni tak semestinya leading 1. Tapi first row and second row ni kena jadikan leading 1. Untuk reduce ni. Kalau reduce elementary row operation. Okay, ada apa soalan tak macam ni? Okay, second example. Okay, second example. Okay, use the combination of column and row operation. Second example. Okay, use the changing column 1 with column 2. Column 1 with column 2. So we put negative 1 lah, the sign for this operation, negative 1. And then we have to reduce this 4. 0. So we use operation negative 4 row 1 plus row 2. So into row 2. So operation dia tak ada. And then reduce into 0. So dapat 0, negative 6, 6. So we get 0. Okay, this is in the form of upper triangular kan, triangular. So determinant equal to this product. Multiple with negative 1. Jangan lupa multiple dengan yang ni. Yang depan dia punya constant ni. So we get negative 12. Ada apa-apa soalan tak ni? Ada apa soalan?
Tak ada.
Tak ada Faham
Faham.
Faham.
Faham dah. Faham.
And then to evaluate the determinants by using elementary operation. Okay, this is another example. Okay, we have this determinant. Okay, we have this determinant A, B, C, D, F, G, H, I. Okay, equal to -2. Okay, we want to find this determinant of this complicated matrix A, B, A, C, B, D minus G. Okay, this matrix. Okay, then to find this determinant, okay, we have to reduce this matrix into this matrix. The simple one. This first matrix, second matrix kan. We have to reduce the second matrix into the first matrix. Sama juga, you are guna elementary row or column operation. Okay, this one use first step, it use interchange column kan. Column 2 with column 3. Interchange. And then use the second operation R2 plus R3. Because to eliminate the G kan, the G. So you get -1 and then this matrix number 1, matrix 1. So matrix 1, the determinant of matrix, this matrix equal to -2. So -1 multiple with -2. So you get 2. Okay, yang ni pun biasa tanya soalan ni. Contohnya ni. Kasih awak. And then, okay, we look at another theorem. Okay, to find the matrix, the determinant of matrix with zero entries, zero determinant. Okay, let A be a square matrix. Okay, then determinant of A equal to 0 if, okay, use this theorem. There are 3. Okay, if matrix A has a row or column with 0 element. Okay, if the matrix has the 0 entries, have the 0 rows or 0 column. Ni 0 rows kan. So automatic the determinant of A, determinant of a matrix equal to 0. So dia ada 0 rows kat sini. 0 rows or 0 column. First one. Okay, the second one, if two or more column or rows in matrix are identical. Dia sama lah kat sini. We look at this matrix. Okay, the first column equal to the second column. Identical kan, sama. So automatic determinant of B equal to 0. Then the third one, a row or column in matrix A is a multiple of another row or column. Okay, look at this matrix C. Okay, the first row and the third row. Okay, the third row is multiplication 2 kan, by 2. 2 multiple with row 1. Then we get the row 3 kan. So automatic determinant of C equal to 0. Okay, boleh? Ya, tak payah tak perlu nak reduce dia. Tak perlu kita nak guna Sorus rule ke, nak gunakan Cofactor expansion ke untuk reducekan ni. So automatic gunakan theorem ni. And the last one, okay, to find the determinant of elementary matrix. Okay, also use this theorem. Okay, let E be an elementary matrix and let K be a scalar. Okay, determinant of E is based on the elementary row operation. Okay, used to produce the elementary matrix. Okay, this is use the elementary row operation before this. to produce the elementary matrix kan untuk ni. Okay, if we use the interchange row to find the elementary matrix, okay, from identity matrix, so automatic the elementary matrix equal to -1. If you use the interchange row, ni interchange ni betul. Elementary equal to -1. Okay, second one, if we use the operation multiplication a row with constant, if k, to find the elementary matrix, so automatic the determinant of elementary matrix equal to k. And third one, okay, we use the third operation, adding a multiple of one row to another row. So automatic the determinant of elementary matrix equal to 1. Okay, look at this example. Okay, this elementary matrix. Okay, to find this elementary matrix, we use the interchange row operation from identity to this elementary matrix. Identity 1 0 0 0 1 0 0 0 1. Okay, we use interchange row R2 interchange with R3 to find this elementary matrix. So we get 1 0 0 0 0 1 0 1 0. So automatic lah the determinant of E equal to -1. Ataupun you all boleh proofkan lah untuk yang ni kan. Nak proof betul tak dia sama dengan -1. You all boleh gunakan method apa-apa lah. Sama nak guna elementary row operation ataupun kita boleh gunakan Sorus rule untuk proof this theorem. Okay, second one, okay, if we use operation 2 row 1 into row 1 to transform the identity to this elementary matrix, okay, so equal to 2. The operation equal, the determinant of E equal to 2 if we use this operation. And the third one, if we use this operation R2 plus 2R1 transform into R2, so the determinant of E3 equal to 1. Ini you all boleh proof You can proof using elementary operation. Kita boleh proofkan teorem ni. Dapat sama tak determinantnya ni? Kita pun boleh gunakan Sorus rule. Kalau macam size Sorus 3x3 pun boleh guna Sorus rule. Sorus rule 3x3. Okay, so dah habislah untuk ni chapter, okay, this first subtopic in chapter 3. Okay, ada apa soalan tak untuk ni?
Ya ada, madam.
Tak ada. Okay, you all boleh try buat ni soalan tutorial. Saya dah upload kan. Walaupun bukan group saya, boleh buat. Okay, contoh saya tunjukkan yang ni. Tak ada soalan, yang lain ada? Faham
Tak
semua?
Tak ada,
Tak ada,
faham.
madam. Faham.
Faham.
Madam.
Okay, faham, good. Okay, determinant tutorial. Okay, tutorial. Okay, yang saya tick ni you all buat betul ni. Yang saya dah tick ni. Yang kita dah belajar lah ni. Okay, try boleh buat ni. Tutorial 3, 1A, 2. 1A2, okay, 2AB. Saya dah tick kat sini. 3AB. 3AB1. Number 4. 4A2. Number 5 ni pun boleh ni. B1 ni boleh. Okay, number 6 ni. 6A1, A1. BA12. 7. A1. And B. Number 8. A12 and B. Okay. Boleh try buat dulu kan yang ni. Ni kita habis ke awal lah. Lepas ni saya ada nak join online course.
Madam,
Ya.
slide tadi tu ada dalam Google Classroom ke?
Ada?
Tak ada pun, saya tengok.
Macam tak ada lah.
Tak ada?
Ada.
Ada kan?
Kena tekan dekat classwork.
Yelah, tapi dia ada properties of determinant je.
Saya rasa saya dah ambil semua dah. Tak ada?
Di slide ini.
Tak complete madam.
Tak ada? Tak ada? Tak apa, kalau tak ada nanti saya check balik. Saya rasa macam dah ada, mungkin tak. Nanti saya check balik. Okay, attendance you all jawab dah ni, Google form ni juga. Jap. Okay, so kelas kita stop sampai sini je lah. Okay, Google form jawab dalam ni.